Good morning. Good morning, everybody. Well, welcome. My name is Chester ENSLIN. I work for the Johannesburg Stock Exchange, and I'm here today to talk to you about our data virtualization layer that we've implemented at our exchange and the benefits that we managed to achieve through the use of that particular product. I hope you're going to find it interesting and hopefully learn something today about what we've done, and maybe a few little snippets about what happens in the trading world. I've been at the company for about 16 years and recently actually emigrated to the UK. And for myself, particularly enjoying the weather. I've heard that it's sometimes a bit dour here, but I love the weather in this country. So it's great to be here today. I've put a bit of an image on this slide for you. You can see that most people make the mistake of thinking that's a lion, but it's actually a lioness. And I think that's just a nod to the ladies in the business world and the IT world. We often find that the men dominate that particular industry, as I can see here before me. And I really wanted to do a little bit of a nod to the lionesses in the IT world and those ladies that are making a big difference in the work that we all do. So jumping straight into it, who is the Johannesburg Stock Exchange? Well, we're exchange based in Africa, as you can see, in Johannesburg, which is the main city in South Africa. And just for your information, I mean, our market cap is $1.4 trillion. Making us the 19th largest exchange in the world. This is a relative size because when you start looking at the top 5 exchanges, their values are inordinately more than the others. But as you can see, we certainly are one of the more serious exchanges in the world, and you'll be quite surprised in terms of our ranking. So the value of that exchange is very large. Quickly wanted to run you through some of the services that we offer. I mean, you've all seen those movies, those tips on YouTube and things on how to trade. You've heard the guy shouting and screaming, buy, sell, that type of activity that happens, and that is true. That is what actually happens at a stock exchange, except most of it's now done in the online world and not really based on an outcry floor where you would go as a trader to a floor and bid for your shares. We offer that particular service, but we also offer something that's unique in the JSE, and that's called post-trade services. Now, most exchanges in the world will offer you the trading venue or the trading space to do your trading, but post-trade is something where all of those trades that are done are settled at the banks. And we do something called guaranteed settlement at the Johannesburg Stock Exchange. And the only other exchange that offers that type of service is the Canadian Stock Exchange. The rest of them will offset the settlement processes into another institution. So, for example, the LSE don't actually themselves manage the collateral and settlement activity. It is moved off into a separate entity, whereas we do it all under one roof. And I think that's what distinguishes our exchange. That makes things very complicated for us, as you'll see as we get through these slides. So hopefully you're going to find it interesting. First thing I wanted to talk to you guys about is football. I often struggled to understand what is trading all about. You hear all this terminology, and there's this exchange speak that the industry knows, and we all talk about cash equities and bond futures and derivatives of this, and it's a lingo that is spoken within the exchange world, which is very difficult for other people to understand. I often think it's designed so that we can keep people out. Just like we do in IT, we also have all of our own terminology, which the rest of the world doesn't understand. And it's kind of like a little club. So it's very difficult to understand what is trading all about. We see what we see in the movies, which is about buy this share or somebody picking up the phone and doing a deal with the next guy for a lot of money. I mean, what is this industry really all about? And if you think about it, it's like a football match. So the next time you go to football, I want you to think about the fact that you might be watching a trading activity in front of you. And this all comes from an analogy. If you think about what a stock exchange used to be, a stock exchange was a physical venue. It wasn't in the electronic world. It wasn't in the IT space. It was a physical place that everybody had to go to in order to bid or make offers on shares that were available at the time. So it was an outcry floor. That's what they used to call it. And all of the exchanges used to operate like that. I can tell you the New York Stock Exchange still does operate an open outcry floor at the moment, but that's more for nostalgia rather than any real business value that they derive from it. But yeah, I mean, somebody said to me, if you really want to understand what trading is all about, think of it as a football match at a venue. And all you can see there is that a stock exchange is commonly known as a trading venue. It's a place that you can go to do some trading. So if we take that analogy further, you can read for yourselves what it says there on the screen. But basically, when you go to a soccer match, it's been organized as a daily match in several fields for players to play against each other using that football according to the rules of the game, so that spectators, i.e. you, the public, can enjoy the benefits of the match as well as purchase merchandise from your favorite team, knowing that all winnings and losses will be paid. And that's all about the settlement activity that I was describing to you. And that's really what trading is all about. So if you follow those words, I've just gone and replaced them. We facilitate a venue on several markets for the traders to bid against each other using an instrument according to market regulations so that the public, you guys, can enjoy the profits of trading as well as buy data to analyze the market conditions and knowing that all those trades and deals will be settled at the end of the day. So it's very important to know if I have just gone and bought a share for £200 million, that it will be settled at the end of the day. I don't think you as the person benefiting from that would be very happy if it didn't happen at the end of the day. So that's what trading is all about. It's like a football match. And I hope it kind of makes sense to you. It did make sense to me because I worked at Exchange for many years and it was difficult for me to understand these processes, especially with the language that everybody was talking about. All right. If there are any questions, please stop me. I wanted to talk about our first use case that we had at the Exchange. And this was a long time ago, so I'm kind of belying my age. We had this problem which was called the grit in sensitive instruments. And if you think about that novel with Sherlock Holmes, he was trying to examine some evidence. He was trying to get to the truth of something by using a magnifying glass, and there was grit. It was dirty. He couldn't get to see clearly what the evidence was all about. And I thought that was a great analogy for the problem that we had at the Exchange, because we were trying to get to the truth, but we couldn't get there because it was all murky, it was all cloudy. So if we jump into it, you can see the terminology that's used within the markets interchangeably. And all these things mean exactly the same thing. So don't be fooled by anybody that's talking to you online or anywhere in the world. A stock is the same as the security, is the same as the financial instruments. They all mean the same thing. The important distinction to know is that a share is actually not a stock. A share is actually shares of a stock. So just remember that in future. But for the rest of the time, these terms are used very interchangeably. Now the problem is, how do you identify these? How do I know that I am trading on a particular share or stock during the day? What will make that uniquely identifiable? You're all familiar with attributes and databases, with unique IDs and things like that. And we need something like that in the trading world. And we need something that is recognized internationally, because these instruments can trade across geographic boundaries. So you could have a share or a stock that is listed in one continent that could also be made available in another. And it always has to be the same number. So we came up with something, or we didn't actually come up with this, but this was actually ISO that came up with a standard, and it's called ISIN, very simple, International Securities Identification Number. It's an Alpha 12 unique identifier that is used to uniquely identify instruments across the whole planet. So you will find that a share or a company's instrument is always given the same number no matter where you are on planet Earth. So if we look at Apple, you all know Apple, and I bet most of you want to have shares in that company. I suppose it depends on the time of day, but that is the Eisen number that uniquely identifies Apple anywhere in the world. This is a bit of a problem, because can you imagine I phone my friend and I say, I've just gone and bought a share of US, whatever that number is, 03783310005. It doesn't roll off the tongue very easily, and it's difficult to interpret. I mean, we don't speak to each other in numbers all the time. So we want to say, I just bought, 500 Apple shares for X amount of value, or whatever the case might be. So it's very important for us to make it easy to access this information. So if you just did a search on any of the search engines that you've got, you will see something like this, where you see the highs and lows for an instrument and the latest value of that particular instrument. But what I want to draw your attention to is something very small on that screen, and that is that little AAPL. Now, remember, we've uniquely identified an instrument as an Eisen, and we always have attributes that are associated with an Eisen, and in this case, it's the symbol. And you can see that that symbol is very easy to understand. It's not a difficult thing for a human to comprehend. And it's very important to the trading world, because when they speak to one another, they actually phone and say, I've just sold 50 AAPLs, or I have just sold whatever the symbol code would be for a particular share. And it's a common language that the traders use to speak to one another. They don't use Eisen. And you have to be very careful about using the name of the company, because a lot of companies have very similar names. And you'll see in the example I'm about to provide you how that can get misinterpreted. So it's important to understand, and on any of the shares that you go and do a lookup anywhere in the world, you are always going to find the Eisen as well as the symbol. I don't know if you've seen on the TV when there's the ticker at the bottom, you can always see something like AGL with maybe a little arrow and the latest price, or FTSE 100, a little bit up or a little bit down with the latest price. Those are actually symbols. Those little codes that are scrolling at the bottom of the screen all come from the symbol. All right. So why is that a big problem for us? Well, a long time ago, we had a central reference data store system. I'm sure many companies have that. And we had various of the trading applications or sort of ancillary systems needing to connect to the central reference data store. Now, in that central reference data store is your Eisen, is your instruments, all of the information that you need to know in order to trade. And you can see in this example, and this is just an example, it was actually far worse than this, we had multiple systems connecting uniquely to that central reference data store. In this example I've drawn for you, there's 7 different unique connections. So we would find, for example, continuous obligations and scheduling was connecting through to the central reference data store and extracting this instrument information for themselves and for the use within their system, and so on and so forth. I mean, you can extrapolate yourself through that example. Now, that starts to become a bit of a problem because we've got duplication already in the landscape. Ours was very, very bad because it was legacy systems that have been built over the years, and obviously the problem had really proliferated itself over the landscape. So let's take the example of AAPL. So we decide we want to list this particular instrument on the exchange for trading purposes, and we need to make sure that this information is disseminated out into all of the consumer systems. If you take that example, you'll see that we've got AAPL stored in the central reference data store, and we're taking that to the broker-dealer accounting system. We're moving that particular code or extracting that code and provisioning it in the broker-dealer accounting system. Broker-dealer accounting system is obviously a system where the brokers are doing all of the deal management activities. So they bought a lot of shares and they're reallocating it out to the various public members that have been a part of that deal. So that looks great. I mean, you can see the font is the same, the color is the same. There's no interpretation issues that have resulted. But the problem starts to permeate a little bit. So you can see suddenly we have, what is the system? The market surveillance system has extracted AAPL, but it's a different font. which implies in the analogy that there's some nuances that have changed. Now, those nuance changes in the world of trading are critical. You simply don't make them, all right, especially on things like reference data. Imagine a company had listed preference shares of 100, and your interpretation suddenly you change that figure to 1,000 in terms of your market surveillance system. It completely changes the picture of what you're looking at. And you can see the example proliferating itself further, that eventually the clearing and settlement system has got the share AAPL, but it's not quite the same. There are elements or attributes of that particular data that has changed through the interpretation. And this is a real-life scenario that we had at the JSE where we were having these interpretation issues. And of course, we send off APL to SWIFT to do the settlement. Now, the funny thing about it is that if you look at APL, I would have thought that's the Apple share. I mean, if I looked at it as a human, I wouldn't think that there's anything wrong with that. Maybe somebody did a little silly coding error or something like that, but it's not really an issue for me. The reality is that APL is actually for a Pulse Corporation, which trades on the Canadian Stock Exchange. So it's quite a big problem, and we really, really needed to solve that type of issue in our organization. So what did we do? Well, it was very simple, actually. We didn't know at the time, and this was many, many years ago, but we introduced a semantic layer. I'm sure many of you are familiar with this, and something that you guys use. But we connected all of the consumer systems through to that particular semantic layer, so that we could make sure that everybody got the precise version of that instrument into the consumer systems, because they were all performing critical business functions. These systems that I'm describing here are not reporting systems or after-the-fact systems. They are live systems that operate through the day. A market surveillance is there that is watching how the market is flowing. So it simply cannot get its information incorrect. It has to be correct all of the time, or you are going to inform market conditions incorrectly. It's very important in the world of exchange. We obviously went to an RFI, RFP process, and you can see the factors that we used there. Now, because we were new to these types of technologies at the exchange, we weighted service as one of the biggest factors that we wanted to concentrate on, because we were new. We didn't know what we were getting ourselves into, and because we have so many data sources at the institution, we wanted to make sure that we partnered with somebody that would help us in that journey. There were some other factors that also played a key role in terms of what we did. And we eventually settled on Denodo, so we partnered with Denodo, who brought in data virtualization into our exchange, and we did that in 2014. So it was an enormous success. We managed to disseminate that information correctly throughout the landscape, and a lot of certified business units and obviously customers out there, because this data is also made available directly to the public via our website. So because we were doing so well, we decided, well, let's expand this. Let's take this technology further. Where can we take it now? And that sort of steps into the next use case that you're seeing in front of you. It's a little hummingbird, and the hummingbird is very precise and very quick in terms of extracting nectar from the pollen in a flower. And that's the reason why I decided to choose that particular image. But rapidity and precision and intricacy are things that are sort of the life and blood of any exchange in the world. So let's talk about that. Why are we so concerned with speed or rapidness at an exchange? Now, you've all heard of cryptocurrencies and things that are hosted in the cloud. A lot of the sort of low latency or high latency solutions can be hosted in the cloud. But no serious exchange, and when I say serious exchange, it's talking about capital markets and things, cash markets and things, will they allow it to happen in the cloud? The cloud simply cannot provide the appropriate speed for us. So you will see any of the serious trading engines or trading platforms that are hosted in the world will feature these three components, which is obviously a trading gateway, a matching engine, and a market data gateway. And those are the three components that will always exist in an exchange. Speed is very important. It's usually on-premise. It's never in the cloud. And there's things like co-location facilities and things that are used for people to gain market advantage. We are using Millennium IT, which is a technology that's provided by the London Stock Exchange. The London Stock Exchange also uses Millennium IT for their matching. Borsa Italia and a number of other exchanges in the world use that technology. So the question is, why is the speed so important? It's very important for a trader to be able to place an order, get an acknowledgement out of the system, and to be able to operate at speed. And you will see that this happens in less than 60 microseconds on our exchange. I know that some of the other exchanges, for example, the New York Stock Exchange, is aiming for under 10 microseconds. So latency, in other words, not the volume of data or the size of data, but the response times are what are the most important for an exchange. Then we've got the next problem, and you can read for yourself, the fat finger problem. I don't know how many of you have encountered the fat finger problem in your own work. I certainly have, because I'm not fallible. I've released some stuff into production, which has caused some issues. But needless to say, this also happens obviously in the trading world with some devastating consequences. So somebody's gone and typed in, instead of I want to buy 1,000, I want to buy 1,000,000. And you can just imagine what that means for the market. And you can have a look. I mean, it's happened all over the world, Tokyo, New York, LSE. It's even happened in South Africa, but with some pretty devastating consequences, where markets have had to be halted because of that fat finger problem. So what do? We've got a $1.3 billion that we send through our systems on a daily basis. And those are the very high-level view of the systems that we use. You will see that we're using Linux and Windows, very simple with some IBM stuff. And you will see here that the orders flow from the matching engine. We send those trades through to what we call the integration layer of the JSE. And this is where we are hosting the Denodo platform. This is the space where we make all of that trading information available to the rest of the ecosystem for consumption. We do a lot of work with that particular data because we've got to mark up, validate, ensure that it's 100% accurate, and there are a number of rules and things that need to be applied to that information before we pass it down into the rest of the ecosystem. Because as I've just described to you, a trading engine is light. There's no validation, there's no rules that are present, and there's a very, very minimal level of validation that's placed in those platforms because they're designed for speed. They're not designed for other activities. So you will see, for example, we do something called Trade++, which takes a trade that has happened on the trading engine and sends it through to the market surveillance system. And we've also got things like Trade+, which is flowing through into the downstream systems as we go through that ecosystem. And it's very important for us to make sure that we ultimately send those settlement instructions for the correct share, for the right value, with all of the correct attributes, using ISIN and symbols and things like that to be able to differentiate that. So it's very easy for us. We find precision to be quite a simple affair at the JSE because we take everything out of the integration layer or Denodo and we expose it to that ecosystem. And it's quite a wide ecosystem. I understand other financial institutions will have many more systems than what we have. But in this instance, you can see that our JSE human system ratio is 2:1, which means that for every 2 people in the institution, we have a system in place, which is pretty high by standards to the rest of the world, because you might have 1,000 systems at a particular institution, but there are a large number of people working there, usually 50,000, 60,000 people. And that does add complexity for us. And the final slide is really just all around our design, how we've implemented Denodo at the institution. It's very simple. It's not a complicated design. You will see there at the bottom, we've got a number of source systems that we tap into. There are actually 212 of them and different APIs that we consume. I'm not going to run through all of them. I mean, you can read those for yourself. So those are the base views that we have constructed. There are 1,041 of them. And then we use Denodo to connect, combine, and derive the information. And this is taking all of the different sources of information and putting it into a meaningful business term that the consumer systems can take into their particular applications. I'm not going to go into all the different bits and pieces that we use, but essentially that is what we do with the Denodo layer, and we create those derived and interface views, and you will see that we've got 44 canonical models. Now, in an institution of our complexity, having 44 models as the ultimate consumer is a great achievement that we've managed to get to, because it means that our layer has been simplified for the consumption of the business systems or the users out there. And it took a lot of work to get there, but we're there. As you can see, the largest data set is 321 fields, but we've combined data from 45 different sources. Because you can imagine in the exchange, we're getting data from FTSE, we're getting data from Thomson's, we're getting share prices, we're getting trading information, people are doing corporate actions on these shares, et cetera, and the information is changing all the time, and we need to make sure that that data is available and ready for consumption in systems that will value the share, will revalue the share at a point in time and make it available to the public. So it's very important to us that we get all of that information as quickly and as efficiently as we possibly can. And that's that. I mean, we've processed 144 trillion rows. I know people often speak about petabytes of data that they've consumed. The thing that's hidden in this number is the fact that it's a lot of complicated information that we have sent through this layer. And we've achieved these four business values for ourselves. Obviously, agility is something that's important to us. We're able to have developers working on multiple projects at once, because a lot of the information is generalized across the institution, so they all need the same data. So it's quite easy for us to make that available to different projects at our company. Our technology cost is definitely reduced. We do not need such a large amount of data access development within the institution, because it's all been centralized and everything is gathered in one uniform manner. The other thing is, obviously, we've reduced that reputational risk. There have been fat finger problems within our institution, but we've managed to catch them very quickly, which I think has been great. And then obviously data is easy. It's easy to get to this information because it's all uniformly presented in one particular model to the consumer systems. And yeah, we've achieved some great successes by using data virtualization. And I would encourage you guys to think of doing the same. And that is my presentation for today. Thank you.